All right, so today we are talking about compound interest, okay? So with compound interest, it's a little bit different formula, okay? It's still kind of similar where like you have your A, your B, and it's raised to an exponent. But each of these letters have special meanings. So P, still kind of like your A, right? It's your, call it your principal or your initial investment, right? So kind of like the A where it's your initial starting amount. We call it the principal. Okay, so your initial investment, the amount you start out putting into account, right? A, right, what it all equals is the amount of money you would have with interest after X amount of years or T amount of years. So you put your principal into the account and then you gain interest on top of it each year. So let's say after 5 years of gaining interest on $200, all this, your A is the amount you would have after that time period, right? Including the interest you would have gained over those years. R is your rate, your interest rate, okay? Written as a decimal, okay? So it is still we're gaining interest, so we're adding it to 1, but we first, with compound interest, the R has to be divided by your M, which is your compounding periods per year, okay? So a common one would be quarterly, okay? So since there are 4 quarters in a year, your M would be 4 if it was compounded quarterly. If it was compounded monthly, there are 12 months in a year, so your M would be 12, okay? So let's look at an example down below. All right, if you invest $300 into a bank account, $300 that you are investing, your initial investment, that is your P. Your P would be the $300 of your initial investment. So you invest $300 into a bank account, which pays 5% in interest. So 5%, that is your rate, right? But we don't want it as a percentage, we want it as a decimal. Okay, so we're gonna move that decimal 2 times. So it would be 0.05, okay? And then it says it is compounded quarterly, right? So like we talked about, there are 4 quarters in a year. So my compounding periods, my M would be 4. Okay, and then how much money will you have after 6 years? So my time is 6, and we're wanting to know how much money we would have, right? That's what we're trying to figure out. That's our A, that's our question mark, right? So we're gonna fill in the formula. All right, so I don't know my A, that's what we're trying to find. I know my P is 300, so A equals 300 times, parentheses, 1 plus, and then we're putting our R as a decimal, so 0.05 divided by our M, which is 4, parentheses, and then the exponent is going to be 4 for my M. This is M times T, so 4 times 6. Okay, so all we did was just label each piece and then plug each piece into the formula above, okay? So P is 300, we brought down our parentheses and our 1 plus R, our rate is 0.05, our M, our amount compounded per year is 4 times because it's compounded quarterly. And then we have M up here as well, so 4 again, and then times our number of years, which is 6, okay? Now all we're gonna do is just type that into our calculator, just like that. So I'm gonna put 300, parentheses 1 plus 0.05 divided by 4, parentheses, and then I'm gonna raise it. 4 times 6 is 24, or you can put 4 times 6 in your exponent. And here's my answer. So after 6 years, my initial amount of 300, 5% interest compounded quarterly, then I would have about $404.21. And that's it. All right, another example. So Bailey's mom puts $800 into a bank account when she was born. Okay, so that would be your P is $800. The account gained 4% interest. So your R is 4%, but as a decimal, right, that would be 0.04. It is compounded 2 times per year. So your M is just 2. And then how much money will be in there when she turns 16? So your time would be 16 years because she put the money in when she was born. So from birth to 16, our time would be 16 years. So we're trying to figure out our A, okay? So we're gonna plug into our formula, okay? So we have A equals our initial amount. My principal amount is 800 times 1 plus my R is 0.04 divided by my M, which is 2, raised to 2 times 16 in the exponent, okay? So we're just typing this in. So we have 800, parentheses 1 plus 0.04 divided by 2, parentheses, and then my exponent is going to be 2 times 16. And we get $1,507.63. So if Bailey's mom put in $800 when she was born, that 800 would turn into $507.63 when it is compounded 2 times a year with 4% interest gained each year. So our mom didn't have to do anything, just put the 800 aside and it became $1,500. Well, I forgot to hit record, so we're gonna do this again. All right, so determine the P that must be invested at 9% compounded monthly so that $100,000 will be available for retirement in 10 years. So it says determine the P. So for this one, we're not actually given the P. The P is gonna be my question mark. That's what we're trying to figure out. So determine the P that must be invested at 9%, so that's our rate. Our rate is 9% or 0.09 as a decimal. It's compounded monthly, okay? So there are 12 months in a year, so it is compounded 12 times in a year. And compounded monthly so that $100,000 will be available for retirement in 10 years. So our T is 10 years, and then our A, the amount that we want to end up with in our account is 100,000. Okay, so we're gonna plug into our formula over here, okay? Once again, I don't know my P, so my A, I actually know this time. We want to end up with $100,000 in our bank account after 10 years, okay? So I'm still just leaving my P as a P because I don't know what it is. I'm bringing down my parentheses 1 plus, and then for R, I'm putting 0.09. And then for M, we have 12, and then it's raised to the M, 12, times the T, which is 10, okay? So I'm trying to find a P, which means I need to get P by itself. It's being multiplied by all of this, so I'm gonna go ahead and simplify all of this in my calculator. Okay, so we are gonna type in parentheses 1 plus 0.09, divided by 12, and then we're gonna raise it to 12 times 10, okay? And it gives me about 2.45, okay? So we're gonna have 100,000 equals P times 2.45, because that's what all of this equaled. And in order to solve for P, we need to get it by itself. Since it's being multiplied by 2.45, we're gonna do the opposite and divide by 2.45 on both sides. So it cancels out on the right. And then we're gonna do 100,000 divided by 2.45, and we get 40,816.33. So P equals $40,816.33. So this is the amount that they would have needed to invest. This would need to be their initial amount invested, so that after 10 years at a 9% interest rate, compounded monthly, they would end up with $100,000.